Okay guys, good morning. So we've spent the last couple periods kind of talking about our multiplication rules. So today, the next kind of logical progression is going to be to look at our division rules, right? So we'll start by reviewing what we looked at last period. So for the first one, we are multiplying 4a times 5a. So we're going to multiply the coefficients, and we're going to add the powers of the same base, which should give us 20a squared. We'll do the same for the second one, multiply the coefficients, add the powers of the same base. So remember, when we have a variable to the 0 power, it just means that that is raised to the 0. The 14 is not raised to the 0 power, so it's 14 times a to the 0, which is 14 times 1, which should get us 14. We'll do the same thing. We've got 30, and then I've got b to the negative second power. And if we want to go a little bit further with that, we can write it as a fraction. So since the b has been raised to the negative second power, we drop that to the denominator and make the exponent positive. For number 4, we're going to multiply all of our coefficients, which should give us negative 36. I'm going to add all of my powers of a, which should get me a to the 8th. And when I multiply 4 times 10 times negative 1 times 1, I get negative 40. And when I add my powers of b, I get b to the 13th. And for this last one, I'm going to do half times negative 6, and then I'm going to do 1/4 times negative 16. So all together, I get half of negative 6 is negative 3 times negative 4 should give me positive 12. And I'm going to add my powers of a, which is negative 2 plus negative 5 plus 6 plus 1, which of course gives us 0. And that will just leave us with positive 12. So today we're going to be talking about dividing powers of the same base. So usually when I ask this question in class, somebody will answer with something like, well, when you multiply powers of the same base, we add the powers. And since multiplication and division are inverse operations, it would make sense to subtract the powers. And I'll say, okay, that's great. Now let's see if we can prove that that's true. So x to the 7th divided by x squared. Okay, well, if I had to write out x to the 7th, right, expanding it, and expanding x squared, it looks like this. So what can I do? Well, I can divide out one power of x. I can divide out another power of x. So when you divide something by itself, the quotient is 1, which is where those blue ones came from. And my numerator is now x to the 5th power, since I've got 5 powers of x. So certainly it looks like we can subtract 7 minus 2 to get us 5. And we can do the same thing here. I've got 5 powers of a. I've got 1 power of a. So when I divide out my 1 power of a, I'm left with 4 powers of a. And the other thing we could do is we could think about checking it, right? In other words, if x to the 7th divided by x squared is x to the 5th, then x to the 5th times x squared should give us x to the 7th. And we've already looked at that. We looked at that a couple periods ago with our product of powers property. So all you need to get in your notes here is our quotient of powers property, that if we're dividing two powers with the same non-zero base, right? As always with laws of exponents, we need the same base. You're going to keep the base and subtract the powers. So if we do that here, and guys, I'm going to go through this quick because, again, this is a video. I'm trying not to make it 30 minutes long. And at the same time, you know, it's good. The videos are good to have because you can always go back. Okay, so if I'm going too fast or if you are not able to get the notes, that's understandable. Just pause the video for each example. Okay, so here we know that the x in the denominator has a power of 1, so that leaves us with x to the 9th. Here we end up with 1. Did I need to put y to the 0? No, I know that any expression divided by itself is equal to 1. So we could have just cut right to the 1, or we could do y to the 0, which is 1. And here we end up with just a to the 1st, which is simply a. I can do this with numerical bases as well. So the trick here is not to get confused and divide the bases, which we wouldn't probably do yet, but by the end of the lesson, we are going to actually be incorporating a little bit of division. That being said, we keep the base of 4 and subtract our powers, keep the base of 8 and subtract our powers. We know that anything divided by itself, excluding 0 of course, anything else divided by itself should give us 1. And we cannot do this one. 7 to the 5th divided by 3 to the 5th, our bases are different. We cannot simplify. All right, so let's see what happens here. X divided by x to the 5th, well, this is 1 minus 5 is negative 4. So we end up with 1 divided by x to the 4th. Here we have to be really careful, right? I'm going to put the answer, and it's maybe not the answer some of us expected. Where did we get 9 from? A lot of people are going to give me 5. Some people give me -9. I had to subtract my powers, so I had to do 7 subtract -2. Now what happens when we subtract integers? We add the opposite. And of course we do in fact get 9. Once again, we have this case of an expression divided by itself. And here again, we have to be really careful, right? Where did he get the answer 8 to the 5th from? Well, he subtracted the powers. -4 minus -9. When I add the opposite, it becomes -4 plus +9, which of course is 5. So I think we're ready for a now try. So you can pause your video and unpause, and we're ready to go over it. Keep my base of x, subtract my powers. We know that this is just going to give me 1 because the powers are the same. 4 minus -5 is +9. And -8 minus -2 should give us a to the -6, which of course I like to rewrite as 1 divided by a to the 6th. Now what happens if there's more than one variable? Okay, that's what we see on the left. So these are kind of different cases. Well, I'm going to deal with x and I'm going to deal with y. So when I deal with x, 5 minus -2 is 7. And when I deal with y, 7 minus 3 is 4. All right, for the next one, when I deal with a, 7 minus 1 is 6. And b, 8 minus 2 is also 6. All right, now when we have coefficients involved, it's a little bit different, okay? So I've got 12x to the 10th divided by 6x to the 7th. So I can kind of think about this as two different problems, okay? This is 12/6, and this is x to the 10th divided by x to the 7th, right? Two different problems. So I'm going to take care of simplifying the coefficient part, which sometimes is an integer and sometimes isn't. And then I'm going to think about the variable part. So 12 divided by 6 is 2. And x to the 10th divided by x to the 7th is x to the 3rd. So in a really basic sense, in a simple problem like this first one, what are we doing? We're dividing the coefficients and we're subtracting the powers. The problem is that's not always going to work, right? 20 is not divisible evenly by 15. So look at what we have on the bottom. I've got 20/15ths. And I've got x to the 7th divided by x squared. So what happens when I simplify the fraction 20/15ths? Well, I divide the numerator and denominator by 5, and it gives me 4/3. And then I'm going to subtract my powers, which gives me x to the 5th. And if I want to combine this, the x to the 5th has a denominator of 1, so it goes in the numerator. So we end up with 4x to the 5th divided by 3, or you can leave it as what I have in green, 4/3 x to the 5th. All right, first one here is another kind of simple one, right? In the sense that I can simply divide 18 by 6, which is 3, and I can subtract the exponents. 8 minus 7 is 1, so 3x to the 1st. Nice and easy. What about the next one? Well, first I have to simplify the fraction, right? So 28 out of 21, I can divide the numerator and denominator by 7. That's 4/3. Now what about the variable part? Well, when I do 5 minus 8, I get -3. So let's talk about what that means, okay? And this is going to give us a better way of doing this. Well, how would I simplify x to the 5th divided by x to the 8th? Well, I could say that it's x to the -3rd, but what would I have to do then? Write this as a fraction, 1 divided by x to the 3rd. I don't really need to go through all those steps. So the best way to think about it is this. If you're simplifying the variable portion and you don't want to go through and if you want to do this, that's fine. But if you don't go through the process of the negative exponent in the fraction, all you need to do is think about where there's more powers of each variable and how many more there are. So I'm going to show you what that looks like. So I already simplified the 28 out of 21, which is 4/3. Now I'm going to say, well, what happens to my variable? Well, my numerator has 5 powers of x and my denominator has 8. So really what would happen is all 5 powers of x in my numerator will divide out, and they're going to leave me with 3 powers of x in my denominator. Now another way of thinking about that is Where do I have more powers of x? Well, my numerator has 5 and my denominator has 8, so my denominator has more. And how many more do they have? 3, so that's going to be x to the third. How about the next one? Let's see if we can do the same thing. Well, the fraction 8 out of 32 is just another way of saying 1/4. So I'm going to rewrite this as 1/4. And let's ask ourselves the same question. Where are there more powers of y? In the numerator, how many more powers are there? 4. So my numerator is just going to be 1y to the 4th, or simply y to the 4th, and then divided by 4. Let's do the same thing down here. 4/12. Well, 4/12 is 1/3. So my fraction is equal to 1/3. Where do I have more powers of x? My denominator. How many more do I have? Well, 5 minus 2 is 3. So rather than have to go through the whole kind of ordeal of, subtracting the powers, dealing with the negative exponent, rewriting it, you could just think about where you have more powers of each variable. So this would be a good time to practice that, so you can give it a little pause. And then we'll come back. So the first one's pretty basic, right? 32 divided by 8 is 4. 8 minus 7 is 1, so we just are left with 4x. This is another pretty easy one, right? So 70 divided by 14 is 5. Now the problem is, where do I have more powers of x? I have more powers in my denominator. How many more do I have? Well, 8 minus 2 is 6, so my denominator is going to be x to the 6th. All right, how about 8 out of 40? Well, 8 out of 40, if I simplify that fraction, is 1/5. And when I think about where I have more powers of y, I've got more powers in the denominator. How many more? Well, 10 minus 7 is 3, so y to the third. And this one is, part of it's easy, part of it's actually really hard. So if you didn't get this last one, we didn't talk about this today. We talked about this with the last lesson. What's 60 divided by 12? Well, it's 5. What do I need to do with my variables? Well, I have to subtract the powers, but the powers are variables. Well, that makes it even easier. If I don't know what a and b are, I just put my exponent of a minus b. So that one's a little bit more of a challenge. That's more of a 9th or 10th grade type application. All right, guys, so I kept it fairly simple for the homework, in the sense that 5, 6, and 7, the coefficients will divide out evenly. Okay, you're not going to have a fraction there. Number 8, you're going to have a fraction, but it's an easy one. And 1 through 4 are pretty easy. Just keep the base and subtract the powers. Any questions, as always, post them on Google Classroom.